Okay, we're now going to look at exercise 2 on paper 2. Now, this one had some difficulties, but it's very similar to the other one that we did about binomial expansion. Consider the function f of x is equal to 4 times 3x plus k to the 11. So, our first task is to determine the coefficient of the term containing x to the 6th in terms of k. Okay, well, what does that mean? Let's break it down step by step. So the first thing that I want to talk about is when it says in terms of k, because I think a lot of people get thrown by what that means. But all this really means is that whatever your answer is should contain k. Your answer must have k in it. That is pretty much the only meaning in that. When people say in terms of, what they mean is your answer must have whatever it is that you are talking about. If you say in terms of k, it must have k in it. If it was in terms of x, it must have x in it, etc. Okay, so there's that. The second part is this idea of coefficient. Coefficient is going to be whatever number will be in front of x to the 6th. Because when we expand this, there will be an x to some power, maybe the 6th, and probably others, and then there'll be a number in front of it, and we want to find the whole number, everything, not just the NCR, not just NCR. That's very important to remember. It's not just the NCR. But let's actually break it down and let's try and do it. So we have here 4 times, and then inside the bracket, 3, and then x, and then we have plus, and we have k. Now, up here we've got 11. Now here's the question. The question is, when are we going to see x to the 6th? Well, if we were to expand this, let's hold on to this 4, and let's focus on the 3x plus k, first of all. Focus on that. If we were to expand this, we would see that there would be one where we would have 3x to the 11, and then we would have another one where we would have 3x, not to the 11, but to the 10, and then we would have times a k to the 1. Remember, the powers up here, both of those, this one and this one, they must add up to 11. So the next one would be, of course, 3x to the 9 with k to the 2 as the next one. Keep in mind that I'm leaving out a prefactor here. That's the NCR. I'm going to write that below. NCR and the NCR. These are the ones that we're going to get on the calculator later because they're too difficult to do by hand. So when are we going to see an x to the 6th? Obviously, we're going to see an m to the 6th. Sorry, an x to the 6th when we have something like this, 3x to the 6th. Now, what should k be taken to then? Well, if we would like it to maintain that 11, we would have to say k to the 5. It would have to be a 5 that we bring it up to. So that's exactly what we'll do. Okay, now we have to remember, of course, that we still have that 4. So I'm going to put that over here. And then in the middle, I'm going to say, well, that's where we want our NCR term. Now, what kind of an NCR are we going to use in this case? Well, we're going to want to use 11 for the n, and we're going to want to use 6 for the, what do you call it, for the r. And we have to do this because there's really no other way. Now, I'm rearranging it slightly to make room for everything. So this is what we're going to evaluate on the GDC in a moment. What we're going to do is we're going to figure this out because let's look at this and break it down. 3x to the 6th. That's going to be the same as if we kept everything from up here, but we then went on to also multiply by, because if you remember your index rules, you remember that it would be 3 to the 6th and then x to the 6th. The 6th power applies to both of them equally. So you have it on both. Of course, you still have k to the 5th. So now this part here, this is difficult to do by hand, but easy to do on the GDC. So that's exactly what we'll do. And I'm just going to type it in exactly as you see. It's going to take me a moment. So please be a little patient, but I'm going to try my best to get it done quickly. And then I will show you how it's done and what the results should be. So here I have put in on the calculator the following thing. In fact, let me get a slightly better picture than what I just got, because that's a little bit difficult to read. Here we go. So this right here, this is what I type into the calculator. I type in a 4 and then times and then NCR. I can access this either via the menu system. I can press menu and then I can go down to the fifth function and pick combinations. I will show you what that looks like now. It looks like this on the calculator when you press menu. This is one option, but you don't actually have to do that at all. You can, if you want, literally just go down to the keyboard and type N, C, and R. And I think honestly it might be faster to do that. Then the next one is the N, and this is of course 11 because our total number up here, that's 11. And we pick 6 because, well, one of the things we're taking it to the power 2 is 6. We could also use 5, but we're going to use 6 because it makes no difference. It should be the same. And then we take it 3 to the 6th, and we get this number. This is our answer. This right here, this is the coefficient because this is the number that's going to be in front of x to the 6th times k to the 5th. Or, well, it's almost our answer because remember, we were asked to find it in terms of k. That means that we're going to have this, and then we're also going to have k, and we're going to bring that up to the 5th power. So I'm just doing this a little bit sketchy, but there we go. This will be the way that it will look, and this should be your answer because it's suggested in terms of k, so you must keep the k. The next question. Hence, take the derivative of the term containing x to the 6th in terms of k. Okay, well, here's the thing. We pay attention to the word derivative. We pay attention to term containing x to the 6th, and then we see in terms of k. Now, when it says take the derivative, it's usually implicit that it means with respect to x. So you pay attention to the x, and you take the derivative as though the x appeared in some function. So basically, we'll have this. Our f of x is, right now anyway, that we're interested in taking the derivative of, is, and I'm just going to copy all of that. Maybe I can get the whole thing. Yes, I can. Excellent. Okay. It's this whole thing. That right there, that is our function that we want to take the derivative of. How are we going to do that? Well, what's relevant when we take the derivative of a function? The only thing that really matters is the x, and then everything that's in front of it, everything that is just a constant, like this k, this is just a number, this is also just a number. We already found it, actually. The only thing that matters is this x. When we have a power function, the only thing that you must do is say, okay, I'll take that, subtract 1, and then put the 6 out in front. Then, all I have to do is take all of this stuff, all of this other stuff, press copy, bring it down in front, and it's a little bit not fitting, so I'm just going to squish it slightly. And then we also bring down the k to the 5th, which is probably not going to fit as is, so I'm just going to quickly modify it a little bit. And then we put that in front as well. This then is actually our answer. So, but now we have to, again, we would like to calculate it. So we'll take this number, replace this with that, so we'll put in 1347192 times 6. That should be our answer. And again, you can just do this on the calculator. I'm not going to waste your time and show you how that's done, because I imagine that you should be able to multiply two numbers together on the calculator. When you do that, what you get is this number. Then you remember, of course, to keep the k, because nothing happens to the k. And you remember, of course, that it's now x to the 5th. This should be sufficient, and it should be the answer. Okay,